Okay, this is the Type 570 characteristic curve tracer. This is the serial number. See if you can see that there. Kind of hard to read, but it's 5010. Kind of see it there. And so I'm here with Robert Silky with Silky Tubes. And right now he's going to describe what we have displayed on the 570.
Okay, right now we have a new testing 6L6GC, US made, and it was confirmed to test new. It was tested at 250 volts on the plate and screen, and its gain was known to be 6,000 or 5,900 actually, and the plate current was 71. It's essentially testing new. And we have it connected as a pentode right now. Now the problem that I have seen so far with the 570 is that for some unknown reason, has yet to be investigated, the variable DC voltage, which is right here, plus DC, which is intended to be driving the screen, is not reading its full voltage. At the 300 volt level, we got about 150 volts. So with this tube operated as a pentode, we would not expect to see the curves as they are displayed in the data book, because it's not getting the screen voltage that it should. However, we can clearly see that this step generator is working correctly. We can get 12 different grid curves. It's hard to read them, but we've been able to count 12, actually possibly 13 steps. And if we expand it out to a different range, they become more clearly visible. So now I'm expanding the milliamps per division, and as you can see, they collapse down to where they're unreadable. And when you go to a lower current, this is 5 milliamps per division. So we have 5, 10, 15, 20, 25, 30, 35, 40 milliamps, and this is our voltage. And this controls the plate voltage. Number of graticules is 50, 100, 150, 200, and so on. And the plate peak voltage for the sweep generator is at 200. We can go to a higher voltage, and of course the curves will then expand out as they do. And we can bring then our curves back in with a higher voltage. Actually, that's about as high as we can go. So that's 50 volts per division. So that's 100, 200, 300, 400, 500. So for some reason, it looks like our screen is reading a higher voltage from what I can tell. This should sweep to 500 volts peak, and at 50 volts horizontal, that should be 100, 200, 300, 400, 500. So it's actually sweeping quite a bit higher. And this is controlling the different plate resistor load. I've got a 5K right now, and as you can see, it changes the shape of the curve. That's the load line defined by the resistor right there. So there's 10K. So should we wire it into triode mode now? We're going to turn it off. Test off. That kills the high voltage, so I'm electrocuted. And I'm going to put the screen to the plate. Now that should wire the two as a triode. And Scott, you remember what I said the curve should look like?
Yes.
Kind of sloped up. There they are. See that? Just like I said, there's triode mode. And that's 12, should be 12 steps. Now the triode is probably giving us a little bit better representation of the way the tube should be operating, simply because we don't have that problem with the screen volts being inaccurate. There's a beautiful triode right there. Nice triode connected 606. And if I move this over a little bit, there we go. That's real clean looking, actually. Again, that's different peak voltage. 200 volts peak. You can move it over a little bit if you want to see it displayed there. Again, what is it? The brightness is working well. Your astigmatism, focus, looks good. Nice clean trace. Okay. Is that enough?
Okay. Anything else to test on that as far as the tube to display?
Well, we can also look at, we can change the screen to read the grid voltage and move it over here. That's actually looking at the grid voltage of the tube. And we have to change our... Okay, that's actually showing you the grid voltage stepping through the different voltages. And as you can see, I can go for 4, and it looks like it actually gives you one more than what it's reading. I think one of them is 0 as a baseline. Okay. We can expand it out. Move it over. So that does appear to work. Now again, we're displaying the plate. That's a nice looking curve.
Let's see if we can get the serial number here. I've got a little LED light. Let's see what shows up there. Hard to focus at that angle.
Do you want a brighter light? I may actually have a brighter flashlight.
Well, I mean, what? So you can read. I mean, what does the serial number say there?
That says 5010.
Okay, and that's what we've represented on eBay. Do a quick just walk around of the unit here. The power cord. When I was testing it out, I noticed that the original power cord, the rubber connecting the two different sides, was getting brittle. And so I replaced the power cord with a new cord today. I use the original connector that goes into the back of the machine. On the back of the machine, it is a polarized plug that is non-grounded. If whoever buys the unit, I'm not sure in the mod summary, it might include having the modification to put in a 3-prong grounded plug. I have a 3-prong grounded plug off of a 575, and so I'll contact the owner or whoever wins the bid on this and see if they want that included. So that's it. We have the Type 570 characteristic curve reader by Tektronix. Seems to be functioning well. There's a few small things. Obviously, the unit really hasn't been powered on for probably 30 or more years and needs to be calibrated. So that's what we have.